Everyone, welcome to Rakesh sir lecture. Today we are going to talk about deviation produced by thick prism. That means we know the function of prisms is the major function is to deviate the light, right? When the light is going in some direction, it is to deviate the lights. So this is one function of the prisms. Other function of the prisms is to disperse the light. That means if white light is passing through the prisms, it disperses into multiple colors, right? So deviation and dispersion is the two major functions or major uses or major properties of these prisms, right? Deviation, it deviates the light from there, or it will change the direction of light, that is deviation. And it disperses the light, that means it if white light is passing through the prisms, it splits into multiple color. I have here one prism. This is triangular prisms. This I will show you in. This is a triangular prisms. I hope you are able to see. And triangular prism in the sense base is triangle. They are the two parallel ends, right? These two parallel ends identical. So this is triangular prisms. Here is rectangle, here one more surface rectangle, here also one more surface is rectangle, right? So this three rectangular surface will take part in the refraction or for the deviation or dispersion, right? Deviation. So that means if I pass the light through this surface, light will emerge out from the other surface, right? See here, light, if I send the light through this surface, light will emerge out from the other surface, right? If I can show you here, right, we are seeing that I'm throwing the light in this direction, but prism bends that light, deviates the light, and the light is on the, you're seeing my direction is here, you're seeing light, my direction is toward a straight, but you are seeing after deviations the light is right now once I'm changing, now you see, now still the light is that side, because now these two will take part, right? So anyway, this three rectangular surface will take part in the formation of image or deviation of light, right? Now carefully see one more thing. Here this is one rectangular surface and this one is one more, right? So these two rectangular surfaces, between this they are meeting at a point, and this point, the angle formed this meeting point, this angle is called angle of prisms. Here also between this point, between this surface, rectangular surface, and between this surface, you have rectangular, so this is angle and this is called angle of prisms. Between this surface and this surface also you have angle of prisms, this angle. So you have three angle total, but at a time only one angle will be take part in deviate the light. Like if two refracting surface and one angle will take part in refraction. Now see here, same diagram. Triangle is down, triangle is down, triangle is up, triangle down, triangle up. Rectangle surface is one is facing toward two facing toward you, and other two has inclined to form this angle. Same diagram I have kept here, right? This rectangle is facing toward you, one triangle is down, other triangle is, you are seeing this one, this is triangle is top, so this is bottom, this one is top, and these two surfaces, this surfaces and this surface, right? These two surface, I hope you are able to clear. This is one surface, this is next surface, and they are forming an angle here, right? They are forming an angle. These two surfaces are meeting. They are forming an angle, and this angle, this is one surface, this is next surface. They are forming an angle. Now, why am I stressing it more here is because most of the students confused from where this is. They will just, because in the later diagram, I will just draw like this. So this is not triangle. You have to consider this is a prisms, and this is one surfaces, right? This is one surface, this total surface. This is next surface, and of course this is the mini version of this, right? So here will be the this side, and if I take this part, So now this will become the complete triangle, this triangle, top triangle, right? So coming lectures, I will be just drawing like this triangle, right? But you have to understand this triangle means this is refraction occurs through the faces, surfaces. Here also the light will emerge out from the surface, right? So once you know about this, we'll be going now through the deviation produced by thick prisms, the derivation. So before that, I will draw the diagram, a simpler diagram, right? Now, right? Do you want me to draw a little more larger? So, yeah. So this is a prisms, and this prism I told this is one surfaces, this is next surface, and when this both surface, you just imagine this is one surface, this is next surface. When this both surface join, this angle, right? When this both surface is joining, this is forming an angle, and this angle of prism, this is called angle of prisms. So this is the angle of prisms, and from here we can see that now see we are going to see the refractions, how the light passes through the prisms, right? So let's assume the light strikes here. So during my lectures I always tell when you want to refractions or how the transmission of light occurs, always you have to take the help of normal, right? Always you have to take the help of normal. So this is a surface, and let's assume this is the normal, approx normal, right? So this is the normal. So normal to this first surface, I will just name it surface P Q R. So this surface P Q R. So this is the surface, and this surface now, when the light incident on this first surface, surface PQ, what is happening here? This is the original direction of the light, but as you know, this prism is surrounded by air, and prism is made up of mostly glasses, and this prism has a refractive index of mu, right? So the light which is passing through the first surface, what will happen? The light is entering from rare to denser medium, air to glass, right? So rare to denser medium, light bends towards the normal. So this is the normal, so light bends towards the normal, and it, yeah, so light bends towards the, it turns towards the normal, right? It turns towards the normal. Now when this light strikes the second surface, right? When this light now is striking the second surface, that is PR surface, PR, what is happening here again? Again I told what is the behavior of light at this surface. Before that we should draw the normal at that surface, right? So before that I will draw a normal, and normal to this surface. So let's assume this is normal, right? Normal to this surface, and at the second surface, right? At the second surface, see the direction of light ray. This is the direction of light ray. If the second surface would have not been there, the light would have passed as it is, right? Now, because the light strikes at the second surface, and at this interface, light is moving from denser to rare medium. Light is moving from prism to air. Air. So prism to air. So what happens here is light bends away from the normal. Light is moving from denser to rarer medium. So light bends away. This is the normal. So light bends away from the normal. Right? So now light is bending away. I hope this is clear. So now we'll play with some angles. let's assume this is B, or else wait, M N O L. Okay, so L M N O M N J K. Here I'll put K. This point is K. This point is K. And now see the angle now. The angle what you are seeing here, this normal to this is angle I, angle of incidence, and then this is normal to this refracted, this is R1, angle of refraction from the first surface, or better yeah, this is angle of incidence at first surface, this is R1 is the angle of refraction at second surface, and what is this one? This is angle of incidence at second surface, angle of incidence at second surface, but most of the book you will find it is R2, but you have to define what is R2. So R2 is angle of incidence at second surface. So, and this is the angle of emergence, right? Angle of emergence, or we'll tell you this is the angle of refraction at second surface, right? Angle of refraction at second surface. I hope this is clear now. So whatever things you have seen, A indicate the angle of prisms, and this PQR is a prism, like that. Whatever the things has been there, you have to write in the form of word. So once you have done with the word, writing in the word, we'll go with the mathematical equation to find out what is the amount of deviations produced by these prisms, right? So you are seeing what is the amount of deviation. What is the deviation here? This is the direction of light wave. Original direction is like that, right? From here the light bent. So this deviated first from the first surface. This is deviation produced by the first surface, del 1. I have written here del 1. Okay, don't confuse. This is R1. This one is del 1. And because of the second surface, what will happen here? See, this is the direction of light, and because of the second surface, what will happen? This is del 2, right? Because of the second surface, light has bent. Okay, right? But the total deviation, how much it is? The total deviation produced by these prisms, you see here. If I elongate here, so see here, if I keep it like this, so original direction is light, final light ray is turned this much. So from the original direction, light has turned this total, right? This is the final light ray. I have traced it backward. So once I have traced it backward, they meet at a point, and this point, let's assume this point is what I can give name. This point is J. This point is J. So at this point, J, and this one is H. So this is the deviation, total deviation, right? So if I have to find out the total deviation, so if this is del 2, this also will become del 2, vertically opposite angle. This is del 2, this also will become del 2, right? And you know the things, so you have to write in the form of this, all angles also in the form of word. So you have to write, let us consider PQR is the prisms, and what is incident light ray? Mn is the normal, or M to O is the normal, and incident light ray, this is G. Gn is the incident light ray, right? This one is the transmitted, N to K is the transmitted light ray, and K to F is emergent light ray. Like that, some naming and you have to write in the form of word. So I'll focus more on the mathematical equations. So let's see here now. Our goal is, just first see what is our goal. So our goal is to find out the deviation produced by thick prism, right? So deviation produced by thick prisms. So here del, this is del is total deviation, is equal to del 1 plus del 2, del 1 plus del 2, because from triangle, what is this, njk, in triangle njk, del equal to del 1 plus del 2, because the exterior angle of a triangle is equal to the interior opposite to interior sum of the angle. So the exterior angle is equal to the sum of two opposite interior angle. So del is equal to del 1 plus del 2. Del is equal to del 1 plus del 2. Now don't forget this is R1. Yeah. Now then I have to, our goal is to find out del, and if I get the value of del 1 and del 2, then that value I will substitute and I will get del, right? So what is del 1? What is this del 1? See, del 1 can be written as, listen carefully, now del 1 can be written as, del 1 can be written as, what is this? This I is equal to this total angle. See here now, this total angle, because of vertically opposite angle. So I can put here JNO angle, JNO equal to angle MNG, angle MNG, because of what? Opposite angle, vertically opposite angle, right? Vertically opposite angle. So I can put here, what is JNO? So this JNO is equal to angle JNO equal to, this is equal to I, this is equal to I, and let's assume, or this JNO is made up of, see here, two angle is there. JNO is made up of, concentrate here, JNK, this angle JNK, you are getting it, JNK plus KNO, this two KNO. So JN can also be written as angle JNK plus angle KN, see here, angle KNO, angle KNO equal to I. So what is JNK now? JNK is del 1 and this one is R1, KNO is R1, or I can put right del 1 plus R1 equal to I, or del 1 equal to I, if I put this R1 other side, I minus R1, this is equation 1. We got the value of del 1. It's so simple, right? Now similarly we have to do for the, no, same pattern, no confusion, same pattern. You see here now, del 1 from del 2 can be, now del 2 can be written as, del 2 can be written as, what I can write del 2? First I see the angle LKF, LKF equal to this angle OKJ, OKJ, because of vertically opposite, this total angle is equal to this total angle, right? You are getting this? This total angle is equal to this total angle. So what is this? JKO, angle JKO equal to angle LKF, right? LKF, angle LKF Now, or JKO can be written as, see here, JKO can be written as JKN plus NKO, right? So JKO can be written as JKN angle JKN plus NKO plus angle NKO equal to, what is LKF? It is A, angle A, right? So this is equal to A. So, or what is JKN now? JKN, this is del 2. JKN is del 2 plus, what is NKO? NKO, it is R2, right? It is R2, R2 equal to E, or del 2 equal to, what is del 2 equal to? E minus R2. If we go there, say E minus R2. So this is equation 4. Now we got the value of del 1 and we got the value of del 2. We'll keep this in this equation, del 1 and del 2. So let's assume this is our equation. No, this we keep as equation 1. This you keep equation 2. This one is 3. Right? Now, substituting the value of del 1 and del 2, we get in equation del 1 and del 2 in equation 1, we get, what we'll get? See here, del equal to, what is this? I minus R1 plus E minus R2, E minus R2. So what we can write here, again we can plus we'll keep in one side. So I plus E minus, and this R1 plus R2. Just let's see here, minus R1 and minus R2, minus R1 and minus R2. So if I take minus as a common, so if you multiply here, minus into R1 minus R1, minus into plus R2 minus R2, so it means the same, right? So I plus E minus R1 plus R2. Now it's almost done, but we have to write in the forms of angle of prisms, because when the prism is manufactured, it is not manufactured in the because we can measure. See, if you are throwing light, we know how much is the angle of incidence, we know how much it is exiting out, we know I, we know E, but we don't know between what is R and E. We need calculation and all. But during the manufacturing of prisms, they use the term angle of prisms. So somehow we have to convert this R1 and R2 in the form of angle of prisms. So one small calculation we will do, and we can convert this R1 and R2 in the form of angle of prisms, right? So now I will erase this, but don't forget this. Okay, this, let's assume this is equation 4. This is equation 4, and now I will erase this, and now I will erase this, and then we'll see this. But remember this, I plus E minus R1 plus R2. So now see here now. So what is here is, okay, now see, I'll take for that to convert this R1 and R2 with relation to A, right? Because I told you prism manufacturing will be based on angle of prisms, how much angle should be there, right? So this A, so this I have to take consider PNOK. This is quadrilateral PNOK. So in quadrilateral, right, in quadrilateral, what is that? PNOK. PNOK. We know if you do the sum of all quadrilateral, this one, right, this, again this, and this, we'll get 360 degree. If you do the sum of all the angles, 4 angles in a quadrilateral, either a square or rectangle or some other four-sided figure, all the 4 angles is equal to 360 degree. This you have to remember. Likely in triangle we have 3 angle sum is 180. Similarly, we have 4 angle in a quadrilateral, sum should be 360 degree. So here angle A plus this angle plus this angle plus this angle should be 360 degree. Now see here, if I had to write this angle, what I should write? NPK. So angle NPK plus NPK, done. Now I have to write this one, PNO, angle PNO plus, right? I have to write this one. Then what I can write? NOK, right? Angle NOK plus angle NOK. Yeah, done. Now this I have to write means PKO, right? PKO, angle PKO equal to 360 degree, right? Now see here, angle NPK, this is A, because NPK, this is A plus PNO. Earlier only beginning of my lecture, this is the normal, so this is 90 degree, right? So if this is 90 degree, PNO is 90 plus NOK. Where is NOK? So there is nothing, so I can write angle NOK plus, if see about PKO, what is this? PKO, PKO, this is also normal to secant surface, so this is 90 degree. So I'll put here 90 equal to 360. Now see here, if I keep this one side, angle NOK equal to, and move all component to other side of the equation, what I will get? 360 minus 90 minus 90, this minus 90, this minus 90, and minus A. So 360 minus 90 minus 90, 180 minus A. So our angle NOK equal to how much? Just see here. If you do this, 180 minus A. This is what equation number 4. So I'll keep this equation number 5. No doubt up to here. Now see the magic. Now I'll take this triangle NKO. In triangle NKO, again I'll find this angle only, because this is common in both. First I took quadrilateral, now I'm taking this triangle, and this triangle is common in both, right? Sorry, this angle is common in both. So in triangle, now again in triangle, what is triangle? NKO. In triangle NKO, what is there? 3 angles should be equal to 180, as I earlier told. These 3 angles should be in a triangle should be equal to 180. So similar things we are going to write KNO, angle KNO plus angle NOK, angle NOK plus angle this, how can we write? NKO, right? Angle NKO equal to 180, right? Now see here, KNO is KNO, it is R1, it is R1. So R1 plus angle NOK plus what is NKO? NKO, this is R2. So here I can write R2 equal to 180. I will keep this one side, angle NOK equal to this, I'll move other side, this also I'll move other side, plus R1 plus R2. If it go other side, it will become minus, 180 minus R1 plus R2. So see here, minus R1 minus R2, minus into plus, it will become minus R2. So minus R1 minus R2, because if it is going to other side. So this is equation 6. Now something is similar between 5th and 6th equation. And we identify. If you see clearly, it is not something, it is clearly visible actually. It's like this angle is equal to, and this angle is equal to. That means left side of the equation in equation 5th and 6th are similar. That means if left side are equal, automatically right side will be equal, right? Right side will be equal. Now from then we can write that from equation 5th and 6th, from equation 5th and 6th, we can write, we can write 180 minus a. 180 minus a is equal to 180 minus R1 plus R2. Right side, 180 minus a is equal to 180 minus R1 plus R2. You're getting this one? So now what we can write here is, see here, 180 cancel, even minus will get cancelled, right? 180 minus will get cancelled. What is remain here? You can just go through it, because this is simpler things. Again, I don't want to explain. It's easy to see that you can cancel it. A is equal to R1 plus R2. You got the value of R1 plus R2, you can write A. So wherever I will get the value of R1 plus R2, I can write A. Or wherever I will get A, I can write R1 plus R2. Now, substituting this value R1 plus R2, here we are in equation 4th we have, right? R1 plus R2. So in place of that, I can put what? A. And that's we need, because we need in the terms of A. So that's all. So now substituting the value in of R1 and R2, in equation 4, what we'll get? Del is equal to I plus E minus A, and this is equation 7, and this is the required equation. Right? So till now what we have did, first we have from the original direction what is the final deviation, del we have found, and from the del, you know, del is equal to del 1 plus del 2, because our goal is to find deviation. So this del is equal to del 1 plus del 2. This is our equation. So once you get the value of del 1 and once we get the value of del 2, we can substitute the value and we can finalize. So what we get, del 1, this is the del 1. So what we have done is, we have first take the reference vertically opposite angle. This total is equal to total, and this total can be divided into two parts, del 1 plus R1, and this, then same things we have got. Earlier we have got I minus R1, right? Similar things vertically opposite, this 2 is equal, then this 2 can be written as del 2 plus R2, and then we can equalize, means what will become E minus R2 equal to del 2, right? So this total is E, so E minus R2 equal to del 2. This total is E, right? Opposite, so E minus R2 is del 2. Here also total is I, this is total is I, magnitude wise. So I total minus R2, you will get del 1, right? So after this, then we got a common for this one, R1 plus R2, and something we need to convert that cell. This is also fine, but I told you this should be converted. This is the value of del, but this R1 and R2 should be converted in the form of A, angle of prisms. So for that we have taken 2, right? So once you have done this parameter, just think what you have to do. These 2 things done. Next you have to take the reference of quadrilateral, and you get this angle. You get this one angle, and then you take this triangle. Then this triangle, again this they common, make left side common and right side equalize. So once right side equalize, you will get value of R1 and R2 equal to A, and substitute the value, you will get the deviation, right? I hope this is very clear, and this is very easy to understand also. So what we can write now is conclusion. So deviation produced by thick prisms, del, depends upon, you can write in all the total form, just I am writing shortcut. So you have to write deviation produced by thick prism, that is very, very important because it is thick prisms. In further lectures or coming classes, I will be teaching about the thin prisms. So that time difference equation is there. So del depends upon angle of incidence, del also depends upon what? Angle of emergence, right? Angle of emergence. Then del depends upon angle of prism. That means deviation produced by thick prisms depends upon angle of prism. And you have to write it does not depends upon angle of refraction. Del does not depends upon angle of refraction. Of course, directly doesn't depend, because if you are depending upon angle of incidence, their angle of refraction also will be there, but directly doesn't depends upon the angle of refraction, right? So this completes your deviation produced by thick prisms. I hope this video is useful and informative.